Hello, welcome to practice problems for homework 11A. I'm going to quickly remove myself from the picture and we will jump right into the work. Be back in a flash. Okay, so welcome back. Before we jump right in, there is another thing I want to talk about quickly, and that's preparation for solving these assignments or any homework or in-class or etc. assignment where applicable. So first thing you want to do is watch the lecture. There's a lot of stuff in the lecture that will help you understand and make things go quicker. Step number two is before you try to do practice problems or homeworks or anything like that, solve all the numerical problems in the lecture from scratch. Those are easy to find because those are the areas where we have the red font, and I've solved them along with you during the lecture itself. And then the third thing is to have the concepts, definitions, and formulas handout at hand. So I'm just going to remind you what that is here. I've got it up for chapter 11 here, and this is going to be very helpful in two ways. If you're looking for a formula, you're going to be able to search here and find it very easily, and if you're looking for a definition or something to help you with a conceptual question, it will help you there too. So as you know, this is sort of the Reader's Digest condensed version of the lecture handout, so very, very helpful for review and for solving problems. Okay, so now let's start looking at some problems. These are very similar to the homework 11A problems. So let's go down here. A firm evaluates all its projects by applying the NPV decision rule. A project under consideration has the following cash flows. So at t equals 0, they're going to cash flow out $20,000 a year later for this project. They're expecting to get $25,000 back. And then note here we've got nothing in year 2, and in year 3 we have minus $1,000. So this is actually a reasonable type of cash flow stream for a case where you have a short-term project that's going to require some remediation or some kind of shutdown cost of the project at the end of the project. Okay, so far so good. What's the NPV of the project if the opportunity cost of capital is 10%? Do not round and use 2 decimal places. Okay, so let's see if we can solve this. So all we need to do with the NPV method, it's the simplest, most straightforward method, is we want to discount each cash flow individually back to time t equals 0, and then add up those discounted cash flows, and that's going to be the NPV. So I've reminded us here our opportunity cost of capital, ROCC, always stands for R, opportunity cost of capital. That's 10% here. And what's my PV of this 20,000 going to be? It's going to be minus 20,000 divided by 1 plus 10% raised to the 0. I'm discounting it back by 0 time there. Okay, and what have I got here for this one? I'm going to have 25,000 divided by 1 plus my opportunity cost of capital, 10%, and that's coming back by, got to discount that by a year. Okay, and then for my third one, I have equal to minus 1,000, right? Everything is algebraically correct with the NPV method, so we just rigorously, ruthlessly follow the sign conventions of the cash flows. And I divide that by 1 plus 10%. And remember that this is coming back 3 years because that cash flow happens at end of year 3. Okay, so that's what it looks like algebraically for us or formulaically for us. So let me put these in numerically. Okay, and I can take these two, and because I don't have a calculator, but I want to work with you exactly as if I did have a calculator. Okay, and I've got that. And now I just sum these up, and that is my NPV. Okay, so let's go down here and sum these up. Okay, and what I get for that is 1,975.96, that would be to 2 decimal places, right? Because I'd want to bring that in by 1 decimal place to get 2 decimal places, and that would give me 2. Okay, great. So far, so good. Let's keep going. What's the profitability index, or the BCR ratio, for the above set of cash flows? First of all, remember, profitability index and BCR ratio mean exactly the same thing, all right? And let's think about this. Oh my God, I don't remember what the BCR ratio is. So what am I going to do? I'm going to go over to my concepts, and I'm going to search for BCR. Yep, it's one of our 3 important discounted cash flow project evaluation methods, but that doesn't really help me. Aha, this looks like a definition. Okay, so here's my definition. So I just want it's a ratio, and I want in the numerator, I want to add up the present value of the positive cash flows. Those would be my cash inflows, right? And I want the absolute value of the present value of my cash outflows in the denominator. Okay, so with that in my pocket, I think that I can do this. So I'll say BCR is equal to, so here's going to be my numerator, 22,727.273, and that's all I have in the numerator this time, divided by, and if I want to be really anal about it, I could use my absolute value signs here and say minus 20.23, and add this up. You don't have to worry about the absolute value signs. You can just change the signs of the numbers. And we have here minus 751.315. Okay, and that would be my BCR. Now let me go down and do that for us numerically. And okay, we got a problem with my formula there. For some reason, it's just not liking these things. So I'll just make this quick adjustment. Oh yeah, that's why I need to use the absolute value function in Excel, and I don't want to do that. Okay, so there we go. And I think that should work. And it's 1.095. And clearly, if this were in Canvas, I'd want to say, do not round and represent your number to, say, 2 decimal places or 3 decimal places. Let's say 3, so that would bring us to 1.095. Okay, so there it is, to 3 decimal places. So the nice thing about the BCR is once you have the NPV done, and if you remembered along the way what you did, you can just literally rearrange the present values to get your ratio, and you're done. So you don't have to start from scratch. Okay, let's do another one. What is the correct equation to use as a starting point for finding the IRR of a project with these cash flows? Oops, I didn't want to show you that. So anyway, if you saw that, whatever. The IRR, let's say we've forgotten the IRR also. So let's go to IRR and see if we can find something useful here. Okay, the R that makes the NPV of a project equal to 0, that's good, but I'm looking for something mathy that's really going to help me out. How about this? NPV equals 0 equals, what do I have here? Every stinking cash flow, discount it back to T equals 0, and then add them up, set it to 0. Instead of R or ROCC here, I put in IRR, and that's what I want to solve for. Okay, good. So I remember that. So let's just write it in here. NPV equals 0. Whoops, we want that to be equal to 0, right? And that's going to equal minus 20,000 and plus 25,000 over 1 plus IRR minus 1,000 divided by 1 plus IRR. And remember that cash flow happens at the end of 3 years, so I put that in there. And that's it. This equation right here, this is the correct starting point, and that's as far as I would want you to take it. Just write down the equation, don't have to do any algebra, don't have to do anything like that, okay? And then here's one that some of you have been clamoring for. What is the IRR of this set of cash flows? So here's a case where we have a cash flow at T equals 0, end of year 1, end of year 2, and this looks like something that might be pretty complicated to solve. So let's just see what we can do here. Let's not get too worried. Just start writing out what we need to write out here. So I'm going to have minus 10,000 and plus 1,000 over 1 plus IRR. And you can raise that to the 1 if you want, but you don't have to. And then also plus 11,000 over 1 plus IRR squared. Okay, so this is looking like something that's going to be difficult to solve for IRR algebraically, but we can do it with, notice the hint we have up here with the quadratic formula. So what I'm going to do is I'm going to multiply both sides by 1 plus IRR squared, and that leads me to 0 is equal to, let's also change the sign, 10,000 times 1 plus IRR squared. And now I am changing all the signs here, so I want to say, whoops, don't want to do that. Minus 1,000 times 1 plus IRR, and then minus 11,000 times 1 times 1. Yeah, so we'll leave it just like that. Now this looks to me like it's in this form, right? AX squared plus BX plus C equals 0. And that's exactly correct. So by multiplying both sides by IRR squared, and let me put in there also, then by minus 1. So I also multiplied both sides by minus 1 to get this just in a little bit more convenient form. Now I'm good to go. So now I can solve for x. So going up here to the quadratic equation and just being very careful. So my b is minus 1,000. So minus b is 1,000, and I need the square root of this whole mess, b squared, 1,000 squared. I can leave out the negative sign there because when I square it, of course, it gets positive, etc., etc., etc. You should just look through this carefully, make sure you can match it to what we've got here. And I'm actually not sure this is right, so I'm just going to copy it down here, and I think if I just take that off, I'm going to get a real number here. Okay, so we get 1.1, and remember that's x, which is equal to 1 plus IRR, so IRR is going to be x minus 1, so let's put that in here. Okay, and that's 10%, but now we're not quite done because remember there are always two possibilities for x here, so I've got to go and take this, and where I had plus the square root, right, I've got to now take minus the square root, and I get for x minus 1, okay, and IRR is going to be x minus 1, right, so I take my minus 1, and I get minus 200%. Okay, and now we want to remember a little bit about the IRR. That first of all, it's okay to use in a project like this where we have one negative cash flow and all the rest are positive, or all negative cash flows and the final one is positive, something like that. Total of 4 possibilities here. These could also be flipped across the y-axis, and that would give us 2 more possibilities. And also, in these cases, the correct IRR is the smallest real positive root. Okay, so that is clearly a negative root, so this is our smallest real positive root, and so this is the answer. Okay, and I think that does it for this round, so thanks for your time and attention, and I'll be back again with you very soon.